We're given an indefinite integral and asked to find the partial fraction decomposition of the integrand and then find the antiderivative. The first step in determining the partial fraction decomposition is to write the denominator in factored form. So the numerator will stay the same, and then to factor x to the fourth plus x squared, we'll factor out the greatest common factor of x squared, so we'd have x squared times the quantity x squared plus 1. And now the factors of the denominator will help us determine our partial fractions. We do have to be careful though. Looking at the factor of x squared, we want to think of x squared not as a quadratic factor, but as a linear factor repeated, meaning x squared is equal to x times x. So our first fraction will have a denominator of x, where we have a linear factor, so we'll have a constant numerator, which we'll call a, plus, now because we have a repeated linear factor, our next denominator is going to be x squared, but the numerator will still be a constant, which we'll call b, plus our third fraction. Our third fraction will have a denominator of x squared plus 1. Now this is a quadratic factor, and therefore we'll have a linear numerator, and we've already used a and b, so it'll be in the form of cx plus d. Now we want to find the values of a, b, c, and d to determine the partial fraction decomposition. So the next step is to clear the fractions from our equation, which will give us what's called the basic equation. And we'll do this by multiplying both sides of the equation by the LCD, which would be x squared times the quantity x squared plus 1. So on the left side, notice how these factors divide out, leaving us with 3x to the third plus 9x squared plus 2x plus 6. Now we need to be careful here on the right. Notice how for this first product, this product here, one factor of x would simplify out, leaving us with ax times the quantity x squared plus 1. Now for the second product, notice how the x squareds divide out, leaving us with b times the quantity x squared plus 1. And then for the third and final product, notice how the factor of x squared plus 1 simplifies out, leaving us with plus cx plus d times x squared. Now to help us determine the values of a, b, c, and d, we'll use the process of equating the coefficients. So for the next step, we'll multiply out the right side of this equation. So we'd have ax to the third plus ax. Here we'll have plus bx squared plus b. And here we'll have plus cx to the third plus dx squared. And now we'll group the x cubed terms together, x squared terms together, x terms, and constants. So notice how there are two x cubed terms here and here. Let's go ahead and factor out the x cubed. So if we factor out the x cubed, and we put the x cubed to the right, notice how we'd have a plus c as the coefficient. Next are two x squared terms. We have plus bx squared plus dx squared. So if we factor out the x squared, we'd have the quantity b plus d times x squared. And notice how there's only one x term and one constant term. So we have plus ax plus b. And now because the coefficients on the left must be equal to the coefficients on the right of the like terms, notice how we have a plus c must equal 3. B plus D must equal 9. A must equal 2. And finally, B must equal 6. Well, notice if A equals 2 and A plus C equals 3, we know C equals 1. And if B plus D equals 9, and we know B equals 6, we know D must equal 3. Now that we know the values of A, B, C, and D, we'll perform these substitutions here on the right side of this equation, which will give us our partial fraction decomposition. Let's go ahead and do this on the next slide. the partial fraction decomposition of the integrand would be a divided by x, or 2 divided by x, plus b divided by x squared, or 6 divided by x squared, plus cx plus d divided by the quantity x squared plus 1, and since c is 1 and d is 3, we'd have the quantity x plus 3 divided by the quantity x squared plus 1. Which means we can now find the antiderivative in this form rather than this form. So now our new problem is we want to find the integral of 2 divided by x plus 6 divided by x squared plus the quantity x plus 3 divided by the quantity x squared plus 1 with respect to x. Before we do this, though, notice how we'll have to change the form of this term by moving this up into the numerator and writing this as 6x to the power of negative 2. And notice how for this third term, use substitution is not going to work in this form. We'll have to write this as two separate fractions. So write this as the integral of 2 divided by x plus, write this as 6 times x to the power of negative 2 plus, here we'll write x divided by the quantity x squared plus 1 plus 3 divided by the quantity x squared plus 1. Now we'll break this up into 4 separate integrals to find the antiderivative. To save a little bit of time, I wrote this as 4 separate integrals, and then notice how I factored out the 2 here, the 6 here, and the 3 here. Now we'll find our antiderivatives. So we'd have 2 times the integral of 1 over x is equal to natural log absolute value x. So we have 2 natural log absolute value of x, plus here we'd have 6 times, we'll add 1 to the exponent, that would be x to the power of negative 1, divide by the new exponent, that's going to be negative 1, plus here we'll perform u substitution, where we'll let u equal the denominator. So notice if u is equal to the denominator of x squared plus 1, differential u equals 2x dx. Notice how we only have x dx. So if we divide both sides by 2, if we write this in terms of u, we'll have an extra factor of 1/2. This would be equal to 1/2 times the integral of 1 over u du. So the antiderivative would be 1/2 natural log absolute value of x squared plus 1. Notice how here x squared plus 1 is always positive, so the absolute value is not necessary here. And now for the last integral, we'll use the integration formula given here below. Notice how our antiderivative will involve arctangent, where a squared equals 1, u squared equals x squared, so u is x and a is 1. And therefore, the antiderivative would be plus 3 times 1 over a, which is just 1, and then we have arctangent of u divided by a, which would be x divided by 1, which is just x, and of course plus c. Let's simplify this one more time. So we have 2 natural log absolute value of x. Here we'd have minus 6 over x, and then we have plus 1/2 natural log. Again, the absolute value here is not needed, so we have the quantity x squared plus 1, and then we have plus 3 arctangent x plus c. So there was quite a bit of work in this problem in determining our antiderivative. I hope you found this helpful.